And so let's talk about images. And so here's an image, right? So that's our current topic is images. And we really want to learn how images are represented on a computer. And we're going to do that using this idea of a 2D list to see how images are represented. And so we have this heart right here. And we have these squares. And you'll notice we have white squares and we have red squares. And it's drawn in this kind of grid. And so this image here is kind of like a grid, a 2D grid with a height of 9 pixels and a width of 7 pixels. And each one of these squares is called a pixel. That's why I said it's a height of 9 pixels and a width of 7 pixels. Each one of these is called a pixel. So we have white pixels and we have red pixels. And let's think about how we could store this kind of data in Python. I want to be able to put this in Python because obviously that's what we're programming with, so we can do stuff with it. Now, the last class we had, not the review, but before the review, we had this concept of a two-dimensional format with rows and columns. And so let me kind of draw that. So we had 0, 1, 2, 0, 1, 2. And so we have this concept of rows and columns. And this is a 2D list, right? It's basically what a 2D list looks like. I mean, we can kind of see this example here. It's almost the same thing as that. Obviously, in Python, we introduce that as a list of lists, but it looks kind of like a grid. So we have this grid, we have rows, we have columns, right? These are the rows, and these are the columns. And we can store it as a 2D list, but we have to think about, to store this, we have to think about what a pixel is. Like, what is each of these pixels representing? What is a pixel? Now, in last week, we saw that we had a table and we had some data on the table, temperatures of the different cities. In San Diego, we had like in the 70s, and Anaheim was in the 80s, and then Vegas was in the hundreds, and not that high, but in the 90s. You know, it was all these various temperatures represented like that, right? And so that's what that table looked like last time, something like that. So we have that concept of this kind of table. But for images, we don't have temperatures, we have pixels. And so let's redraw this table. And we have a very small picture here. Let's just say this is 9 pixels, a 3 by 3. So we have 9 pixels here. And so for an image, we have to figure out what we're going to store at each of these pixels. And what we store on pixels is the color. A pixel is actually a color. It represents a particular color. On this image, we have white, 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 and all more whites. And then up here on the second row, we have red, white, red, and etc. So we store the color of the particular pixel. And so this pixel only had 2 colors. And so what if in this little image here, what if we wanted red in the center? And then maybe, and unfortunately, I cannot draw white because white doesn't show up on white. So I'm going to leave these alone. But to demonstrate white, I'm going to use gray. So then we have some whites. And then let's say the last of the pixels in here are going to be black. And so then these are going to be black. And so we have white, black, and red. And to represent a color on a computer, we use a model called RGB. Red, green, blue. And what these values represent is how much light is produced on a computer screen for the red color, the green color, and the blue color. Every pixel on a computer screen is made up of 3 little lights. And it can turn the intensity on for red, green, and blue at various levels. And these levels, this range of levels, actually go from 0 to 255. And for those of you that know a little bit of math, you'll know that's 2 to the 8. So it means it's 1 byte. So each color is 1 byte of information. So it gives you 0 to 255 values. And so the value of red in our image above and we want to look at the RGB values of red. It's full intensity, or 255 red. There's no green and no blue. So it has the 255 is the most intensity of that particular color, and 0 means the least intensity of color, which basically means there is no green, there is no blue. Then we have the white, and again, I didn't have a white, but the white would actually be 255, 255, 255. So white is made up of full intensity of all 3 colors. And then we have black. And black is 0, 0, and 0, which is no red, no green, no blue, no light at all. Everything is black. Obviously, on a computer, I don't know if you've ever seen, probably have seen a monitor that was everything was all black, and it still has that kind of a sheen of color to it. There's light there, but they're all black light. And we can store this information in a list. So we can actually take this data here and create a 2-dimensional list. Of those pixel values. And the first one, and this is going to be pretty hard for me to write because I have a lot of information to write, is going to be 255, 255, 255, because it's white, white, white. And then the second one is black, and black is 0, 0, 0, then white. And then in the middle, whoa. In the middle, we have the red. And so we would go through and fill in all of those color values and store it in some kind of data, right? Just assuming right now we have some data format that can hold 3 values. So this is how it would be stored in a computer. We would have a 2-dimensional list that holds these 3 values for every pixel. And so we'll go into more details on how to represent those 3 different numbers in a single location in a 2D list in a minute. Let's go back to our heart. So for this, we look at, oh, what's that white pixel? That's our 255, G 255, B 255, right? That's what's going to be represented by that location. And then for the red, we know that's 255, 0, 0. That's what's going to be stored at that particular location. So every particular cell is going to store some combination of those 3 values, the R, the G, and the B. And then that gives us the color at that particular pixel, that particular cell. And we can represent, if we can find a way to represent these numbers here, we can say, well, this is red, and we know it's red, and we know this one up here, we know this is white. And so we can start determining what these colors correspond to in terms of pixels. And this is just how the basics of images work. Essentially, we have all these pixel values. And by the way, the images we're talking about here are mostly JPEGs and PNGs. So those of you who know Photoshop might know there's actually a fourth color for PNGs, and we're going to ignore that fourth color because we're not going to be using it. And any questions about this before I go to the quick poll? Okay, so here's some images here as well. Remember, we have the heart. Here we have a yin and yang, two colors representing the darkness and lightness, but we only have two colors. You'll notice here we have a pumpkin, which is made up of orange, and then black for the shading in the edges. And then there's a brown little stem up here, some brown pixels, and then everything else around it is white. And we have Santa. And you notice he's got a green bag. And then he's got black pixels for his outline border in his eyes. And he's got a, red in here for his suit and hat. And then white for his beard and part of his hat as well. And then he's got yellow in here for his belt buckle. And color combinations like yellow, so to reach yellow, so on a computer, color is what we call additive. And so a combination for yellow would actually be 255 red, 255 green, and 0 blue. And that creates yellow. I can't remember what brown is, but it's a variation of red and a little bit of blue and a little bit of green. And so by combining colors or combining these intensities, we get new colors by mixing these values of the R, G, and the B. And as a little tool to help you, which I have just dropped in chat for all of you, this is just a kind of basic color schemer. And we can put in colors in here, and we're only worried about RGBs. I'm not worried about this hex. If you do web graphics, then that hex thing is actually important for web graphics, but we're not doing web graphics. And you see reds right there, and here's yellow, 255. And then here's white, which is all of them. And then, by the way, gray is variations of white. So if you reduce the intensity of white, you start getting grays. And the less color you have, the less smaller the number, the darker. So we actually could do 255, 00, get red. Whoops. And then if we drop that to only 100, which is a darker red. So we can vary the intensity to vary the darkness of the color. So this is a nice little way of actually checking and playing around with colors. If you want to see what green looks like. And here's a little brown, or green and blue, we get that. And then you can mix variations to get other kinds of things. So the reason I pulled that in there for all of you is that we're going to hit some other colors that you may not know.